Today, we're discussing a feature that has just been updated in version 5.4 of Unreal Engine. It is now stable and fully usable for integration into a video game, for example. As you can see, we talk about the custom gravity. I'll explain how to set it up by integrating a new player controller system using C++ code. Let's get started. To begin, note that you can create custom gravity directly via blueprints, but you'll encounter difficulties, particularly due to our mouse system coordinates, which is always relative to the world with z negative. When we have our head upside down, we must take this into consideration, otherwise our camera controls will be reversed. To simplify this and avoid creating complex blueprint logic, we'll directly create a new class in C++ to create, as I've already mentioned, a new player controller. I based this video on the step-by-step provided by one of the developers at Epic, Harry Arnbrodsson. He did an exceptional job, and I wanted to make a video to cry for certain parts, especially those regarding C++, to help you overcome any difficulties you might encounter. Indeed, I encountered some small difficulties, and I thought, hey, I think some people will struggle at this level, so I need to clarify it all. We're not all as talented and comfortable with C++, right? Firstly, I invite you to create a new project, starting from the third-person template with version 5.4, of course. Remember, you can start here with the blueprint base and still intervene with C++ and vice versa. You won't be blocked in any way. Once created, you can go directly to Tools, then New C++ class. We'll choose the first option, which is an empty class here. After clicking Next, we'll rename our class to Gravity Controller. Click on Create Class, and after the code has been added to the project, click OK. Then in the second pop-up window, click No this time. We'll adjust a few things before proceeding. You can now close Unreal and go directly to your Windows folder where your Unreal project is located. We'll find common folders there, like Config and Content. Additionally, as you can see, we have new elements created here, such as the Source folder. We'll focus on this one first. Open it, then also open the subfolder named after your project. We'll edit the last two elements, namely the Gravity Controller .h and .cpp files. Let's start with the second one, the .h file, by right-clicking and choosing to open it either with Notepad or, like me here, the simple version of Visual Studio Code. Here we don't have anything conclusive since we started with an empty class, remember. So we can delete everything and use the code that Harry graciously composed for us. I put it in the description to make it easier for you. The code here will allow us to implement the transition logic at the rotation level based on the world to those based on our new gravity. This creates two new U functions in the matrix that we will later find in blueprints. Save your code and let's move on. Let's continue with the .cpp file. Same practice, let's first delete the basic elements here and copy the code portion that Harry has created. This part will mainly manage our camera movements in relation to our mentioned custom gravity, keeping a constant axis and orientation without having to manually reorient or compensate our camera with our mouse. The next step, and no less important, is to compile our projects to find the freshly created and adjusted C++ class. But if you, like me, have the simple version of Visual Studio Code, or if you don't have it at all, it's important that you follow the next step well. To compile your project, simply right-click on the .sln file with your project name. Choose to open it with Visual Studio Code. But if it's not the correct version of VS, or if you don't have it at all, as I said, you might encounter this message. But if you persist in opening it with your simple version of Visual Studio Code, you'll get a text format of your code and no possibility to compile and therefore use the local Windows debugger. To remedy this, you actually need to install Visual Studio Community 2022 via Visual Studio Installer. Click Install here and make sure to activate the following items: .NET Desktop Dev, Desktop Dev with C++, Universal Windows Platform Dev, and Game Dev with C++. This last workload is very important. Without it, compile is impossible. Moreover, we'll add other elements here. Once this one is selected, on the right, make sure to check C++ Profiling Tools, C++ Address Sanitizer, Windows 10 SDK 10.0.18362, oh my god, or newer, and Unreal Engine Installer. You're ready now, you can click on Install. It may take a few minutes here because we are talking about over 1000 gigabytes here. You can now retry the operation by right-clicking on your .sln file. Open it this time with the Microsoft Visual Studio version selector, and you will directly see your local Windows debugger available at the top of your interface. Click on it and you're done. After a few minutes of compilation, your Unreal project is ready. If you open the game mode assets of BB third person, you'll find our new class Gravity Controller under Player Controller class. Let's select it and continue. The most tricky part is done. Now we just need to modify some parts of our character's event graph, a few things on its animation blueprint, and later we'll create an actor blueprint with simple logic that will allow us to trigger our custom gravity. Here I'm using a character that's a bit more fun and colorful than our basic mannequin. And I think you've recognized him quite quickly since the beginning of this video. But don't worry, I've done the exact same logic as the default mannequin in Unreal. All the nodal system and functions present by default on our Rudy are the same as the mannequins. If you open the blueprint of your character, we'll focus on and modify first its movement inputs, starting with its left-right logic. Here, we'll reuse the new functions created together via our new C++ class. Disconnect the return value from the getRight vector. Duplicate this last node, and in its inputs, we'll right-click to find the recombine struct pin. Connect the return value of this duplicate to the inputs of the world direction of add movement input node. We'll continue our path here, and we'll no longer need this old piece of code. Starting from the rotation inputs of our getRight vector, we'll look for the node created by our new class, namely the getGravity world rotation. Same operation as before, but in reverse this time, we'll right-click on the rotation inputs to split struct pin. Right next to it, we'll call our second function present in our gravity controller class, namely the getGravity relative rotation. Same operation of split struct pin, but on the outputs of this function this time. Connect the values on X and Z only here, which are the two main manipulation axes. From the rotation inputs, find the getControl rotation of the pawn. From the gravity direction inputs, call the getGravity direction of the character movement component. Don't forget to connect the latter to the gravity direction input of the gravity world rotation function too. We'll reproduce almost the same logic for the forward-backward part here. I'll leave you with the visual, just think that it's necessary to specify only the value on Z between getGravity relative and world rotation. Last configuration step for our character is modifying its animation blueprint. If you select your mesh component here, you can access it directly. In the event graph, we just need to replace that node. Instead, let's call the simple vector length and reconnect everything. We need to specify here for Unreal to take into account all axes, not just X and Y. Because once the character is rotated, we may have problems and kinds of slowdowns on the character itself when you start playing with its gravity. The major part is configured. Now we just need to define how to use this gravity controller and this custom gravity. There are several possibilities here, and I've chosen the simplest and most meaningful in my opinion. We'll base it on spherical objects, planet type, and navigate on them. My logic here is to create an actor that will define the relative gravity of our character at each frame, so that it can truly work all around our little planet. Since it's every frame, it logically means event tick. Indeed, we'll start our construction on the event graph of our character, starting from event tick. From this, we'll look for the isValid node with the question mark next to it. Among other things, it will allow us to specify an input object, which will be a variable in soft object reference so that we can recall and define it on our blueprint actor that we will create just after. Before going further, let's create a variable that we'll name targetGravityActor. Change its class with ActorSoftObjectReference. Drag it into your graph in Get mode. Before connecting it to the inputs of our isValid node, let's add a ResolveSoft reference to properly connect it. And it should automatically do it by itself. Let's continue our code development here. From the output isValid, find the function setGravityDirection with the character movements as the target. For the input gravity direction, we will the following logic. First, let's use a vector normalized to implement a tolerance. From our input A, let's find a subtract. With this, we'll create the gravity logic between our character and the actor that we'll define later, which will also define our variable here. So on the two inputs of our subtract, we'll use a getActorLocation. The first with our variable as the target and the second as self. Congratulations, you've been following perfectly from the beginning, and we are almost there. Just one last asset to create. So now let's create a blueprint actor that will trigger our new gravity and therefore also define our variable freshly created in our character blueprint. In your content drawer, create a new class of blueprint actor. Let's call it BP_actorGravity. Without making it complicated, let's just start with a sphere collision as a component here. Let's enlarge it a bit, but don't worry here, we can adjust the size on our viewports manually afterwards. Our sphere collision here will play the role of a trigger volume in which we'll place a static mesh, our planet. In its event graph, here's the logic to have. First, select your collision components to find the two events on component begin overlap and on component end overlap. Starting with the begin overlap event, let's find the actor concerned that contains the variable to define. Remember that. That's why here we use the cast2 with the name of your character. Also remember to connect the other actor here. The last step here is to define the variable target gravity actor contained in our character. Starting from the execution wire of your cast, find the set gravity actor under the class of your character. We are calling our variable in set mode because it's here in these preprints that we are defining it. The dynamic and easily changeable way that I have set up here is to promote the input target gravity actor to a variable. I rename it on target gravity actor, and importantly, I activate its instance editable, notably by clicking on the closed hide here. Same logic for the end overlap events, except that I recreate another variable here, naming it end target gravity actor. And also remember to make it editable and thus expose it. It's time to test all this, isn't it? Drag and drop your blueprint actor in your scene. I've set up a nice little scene for our famous Woody. Now all that's left is to drag a static mesh inside the collision volume of your blueprint actor gravity. You can take a primitive or any custom static mesh, just check its collision presets, and especially its pivot points. Indeed, if it's not in the center, you will have a result that's not at all conclusive. Once your mesh is inside, and as I did here, all you have to do is specify your export variables on your BP_actor gravity. Here I've repeated the same object twice, but you can, for example, create multiple planets with different targets, variables, or trigger zones, and play dynamically and as desired with these export and modifiable variables directly in editor. By stipulating the same actor, if I jump, my character stays on the same actor. If I stipulate another mesh, I'll be able to switch my gravity targets on the fly. You've understood? We could create many super cool effects with this logic. And I found this feature super interesting and really incredible. We'll be able to create extraordinary experiences and video games with that. Everything works, our characters follows our planet well, the camera too, and it's awesome, really nice. Thanks for watching, don't forget to leave a like and subscribe to our channel. Thanks for your support guys, and see you very soon, bye!